Welcome back to Miss Bioscience. So far, we have covered some basics about evolution, natural selection, and adaptations. And we are using these to answer the question, what does it mean to be human? This week, I thought we could cover our closest living relatives, our similarities, and our differences. I will be using The Gap by Thomas Suddendorf as my main source, so if you would like to read this book, I will link it in the comments. Let's start with a simple but humbling statistic. Humans and chimpanzees share approximately 98% of their DNA. What could possibly be in that 2% of DNA that makes us so different? Or are we even as different as we thought? Take a look at the things we have in common. According to our DNA, that should be the majority of our traits. Humans are primates. Primates include lemurs, New World monkeys, and apes, and we have many unique adaptations. We have forward-facing eyes with colored vision and a reduced reliance on our sense of smell. We all have grasping hands with opposable thumbs, precision grip, and fingernails in place of claws. Primates are also known for their larger brains. Why the need for big brains, you may ask? You'll have to come back at a later date because it's a little too complicated to dive into this short video. But you should know that some of our behaviors that we consider human are not ours alone. For example, vervet monkeys recognize relationships between each other. According to Suddendorf's book, when a baby is calling, the other vervets will look to the baby's mother, recognizing her as the individual the baby is seeking. Additionally, when two chimpanzees get into an argument over grooming or food, the other chimpanzees will choose side based on kinship to the original arguing parties. Sounds like an extended family Christmas party, doesn't it? Primates use tools too. They are not nearly as sophisticated or complex as our own tool, but it is highly advanced if you compare it to other parts of the animal kingdom. This tool use is also learned, where individuals are taught how to use the tool and can pass this down to their offspring. We also have rotationally blessed shoulder joints. Smaller primates like gibbons will use these flexible shoulders to swing through canopies at great speeds, while humans and chimpanzees may use this range of motion to throw with precision. Laughter is another similarity. Other great apes love to wrestle or tickle and will make vocal sounds that are like laughter. According to Suddendorf, they too find the armpits and belly especially ticklish. As our closest relatives, chimpanzees can be alarmingly human-like in their behavior. Not only do they live in large social groups with very complicated relationships, they can also go to war. Male chimpanzees will patrol the borders of their territory and fight groups of chimpanzees that trespass. These conflicts are incredibly violent and have been well documented by Jane Goodall in her research. It's been suggested that they have even entered their own Stone Age in terms of tool use. So where does that leave us? That's quite the list of similarities and what's left for differences. Humans are obligate bipedals. So while primates may walk on 2 feet from time to time, they can only do so for a short period of time. Imagine how you feel trying to walk or crawl on all 4 limbs. You can do it, but it's rather uncomfortable unless you're about 6 months old. While I personally appreciate walking on 2 feet, I am sort of sad about the loss of grippy feet. Being bipedal means that our big toes aren't opposable, and so they aren't able to grasp anymore like they might for chimpanzees or gorillas. Humans also have a larger brain, even in terms of primates, and it's slightly reorganized. We will go more in depth in a later episode, but here are some basics. For our body size, we have one of the largest brains in the animal kingdom, and we invest somewhere around 25% of our calories to keep that brain running. We also have a highly folded brain, even compared to primates, that allows for more brain power in a smaller space, and that folded brain has way more neurons. Our brain also has slightly less space designated for vision and smell, which leaves more room for other cognitive processes. This is where most of the differences in human behavior comes from, our ability to talk, learn, advance, and adapt. So when you take inventory, bipedalism and brain evolution is what has really driven the gap between humans and our closest relatives, but that gap might not be as big as we would like to believe. What do you think? Leave your thoughts in the comments, and we'll see you next time.